Our planet, Earth, formed over 4.5 billion years ago. It was a time of intense heat and volcanic activity. From this chaos, a celestial dance led to the formation of our moon. Evidence suggests that a Mars-sized object collided with the early Earth, ejecting debris that coalesced to form our lunar companion. As Earth cooled, oceans formed, providing the crucible for life's emergence. The earliest traces of life are faint whispers in the geological record. They date back to approximately 3.7 billion years ago. These early life forms were simple, single-celled organisms, likely resembling bacteria or archaea. They thrived in environments vastly different from our own, relying on chemical reactions for energy. Their existence hints at the remarkable tenacity of life, clinging to a young and volatile planet. One of the most significant discoveries in the early fossil record is the presence of stromatolites. These layered structures formed by colonies of microorganisms provide tangible evidence of early life's presence. Stromatolites, found in ancient rocks around the world, serve as a testament to the long and fascinating journey of life on Earth. The early Earth was a world of extremes, but it was amidst these challenges that life found a foothold. These first simple organisms paved the way for the incredible diversity we see today. Their story is a reminder that even in the harshest environments, life can emerge and thrive. A revolution was brewing in Earth's primordial oceans, a revolution that would forever alter the planet's destiny. This revolution was driven by the emergence of a new process, photosynthesis. Cyanobacteria, a type of bacteria, developed the ability to harness sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. This seemingly simple process had profound implications. Oxygen, initially toxic to most early life forms, began to accumulate in the atmosphere. This marked the beginning of the Great Oxygenation Event, a period of dramatic environmental change that occurred roughly 2.4 billion years ago. The rise of oxygen led to the decline of many anaerobic organisms for whom oxygen was poisonous. However, the rise of oxygen also paved the way for the evolution of new life forms that could utilize this abundant gas. Aerobic respiration, a more efficient way of producing energy, emerged. This metabolic process allowed organisms to thrive in oxygen-rich environments and fueled the development of more complex life forms. The Great Oxygenation Event was a turning point in Earth's history. It marked a shift from an oxygen-poor atmosphere to an oxygen-rich one, shaping the course of evolution and setting the stage for the rise of complex life. The world was forever changed by the power of photosynthesis. Life on Earth remained microscopic for billions of years. Then a profound transformation occurred, the emergence of eukaryotic cells. Unlike their simpler prokaryotic counterparts, eukaryotic cells possess a nucleus which houses their genetic material and other specialized structures called organelles. The origin of eukaryotes is thought to be linked to a process called symbiogenesis. This theory proposes that one prokaryotic organism engulfed another, forming a mutually beneficial relationship. Over time, this partnership became so intertwined that the two organisms evolved into a single, more complex entity. This revolutionary event gave rise to the eukaryotic cell, the building block of all complex life. The evolution of eukaryotic cells paved the way for another major transition, the emergence of multicellular life. Around 1.7 billion years ago, single-celled organisms began to cooperate and form colonies. These colonies, over time, evolved into more complex organisms with specialized cells and tissues. Multicellularity allowed for greater complexity and diversity of life. Organisms could now grow larger, develop specialized structures, and occupy new ecological niches. From simple sponges to towering trees and intelligent animals, multicellularity opened up a world of possibilities, leading to the incredible diversity of life we see today. The history of life on Earth is a story of constant change, punctuated by periods of rapid diversification and devastating extinction events. The Cambrian explosion, which occurred about 540 million years ago, witnessed an unprecedented burst of evolutionary innovation. During this time, most major animal phyla appeared in the fossil record, showcasing a dizzying array of body plans and adaptations. The oceans teemed with trilobites, bizarre creatures with segmented bodies and compound eyes. Early fish, the ancestors of all vertebrates, swam through ancient seas. Life on land also began to flourish, with plants colonizing the continents and the first terrestrial animals venturing onto land. The Cambrian explosion marked a pivotal moment in Earth's history, a time when the blueprint for much of modern life was established. However, life's journey has not been without its setbacks. Mass extinctions, periods of rapid environmental change that wiped out a vast percentage of species, have repeatedly reshaped the biosphere. The Permian-Triassic extinction, the most severe extinction event in Earth's history, occurred about 252 million years ago. It wiped out over 90% of marine species and 70% of terrestrial species, dramatically altering the course of evolution. Despite these setbacks, life has always rebounded, evolving and diversifying to fill the ecological voids left behind. Each extinction event has created opportunities for new species to emerge, shaping the tapestry of life on Earth. The vast diversity of life we see today, from the smallest microorganisms to the largest whales, is a testament to the resilience and adaptability of life on Earth.